Do we do this question on Friday? Or do we do this one already? Okay. Correct answer, I'm just going to tell you on this one, is no. They do have the same mass, they have the same speed, but this one's heading north, this one's going south. Good with that? Okay. Tell your neighbor. Correct answer is I heard an A and an E. That's what I got so far. Correct answer is E. Okay. This is going from something to nothing. This is going from nothing to something. This is going from something to something in the opposite direction. Okay, so we are doing, so it's not necessarily like a free body diagram. It's not acting at the same moment in time. We are doing mass times change in velocity. So if I put a number to this, let's say this was a positive 10 meters per second. This is a negative 10 meters per second. Negative 10 minus positive 10 gives you a negative 20. Good with that? Tell your neighbor. Correct answer is B. Beautiful butterflies. Okay? They experience the same force, but this one experiences that force for a greater amount of time. Everybody good with that? Didn't really need to know physics to answer that question. It's a little better question. Tell your neighbor.
Look at this guy. The momentum, so the momentum. Hey, gotta be the same. I told him that.
Correct answer is? Correct answer is B. Okay? They all have the same, they're going to experience the same change in momentum. Therefore, if they experience the same force, requires the same amount of time. Tell your neighbor. Correct answer is? Correct answer is B. Bountiful buffaloes. In order to get it up to the same speed, because they have the same mass, and they started from rest, they're going to have the same change of momentum. Okay? If you have half of the force, to keep this side the same, you need to compensate for that half by going twice the time. Good with that? Thumbs up when you have a guess. Tell your neighbor. Tell them why you think so.
Yesterday when we were doing the lab, we figured out that if we set Wally the lowest mass and the highest amount of force exerted, we could get him to Mars in 2.1 years. It was very interesting. We did finish the lab.
That's fine.
But we definitely got distracted while we were
It's all good.
making notes.
All right. So, what do you say? All right. So, this was actually experiment. Which one was this? Experiment 2 from yesterday. Okay. I'm looking for change in momentum. I've got 2 different ways to approach that. I could look at it from force times time, or I could look at it from mass times change in velocity. Okay. One way is fuzzy. It's not really definitive. The other way is like rock solid. If we look at the mass times change of velocity, we're like, okay, cart A, it has more mass. It's going to go slower. B has less mass. It's going to go faster. They might end up being equal, compensate for one another. Okay? You are trying to be a physics lawyer. You're trying to come up with a case that has no reasonable doubt. Mass times change of velocity in this case, there's some reasonable doubt there. But if you look at it from a force times time, experience the same constant force, both for 1 second. That's definitive. You can't get around that. Like, that is a rock solid case. Does that make sense? That's what you're looking for. You're looking for, all right, I know this, I know that, therefore I know this. Correct answer is B. Good? Thumbs up when you have a guess. Tell your neighbor. Correct answer is okay. This is not asking for which one had a greater final momentum. This is asking for which one experienced a greater change in momentum. A definitely had a greater final momentum. It's twice, yeah, because it's moving twice as fast. But for change in momentum, they experience the same force for the same amount of time. Correct answer is B. You okay with that? Same force, same amount of time. I'll give you a hint. This is experiment 3 from the lab yesterday. Have a conversation.
No, but it's mass. No, it's mass.
Yeah, but if you could more time. It's gonna take more time to do A. A is gonna move slower because it's S. It's the chance. They both start to so A will end up with a greater amount.
Correct answer is
A.
who wins the race? B wins the race. You're okay with that?
Yes.
Has less mass, experiences a greater acceleration. Okay. So, which one is experiencing a force for a greater amount of time? A is experiencing a force for a greater amount of time because it lost the race. It experiences a force while it's on the track, on the course. Does that mean A is going faster? No. Momentum is mass and velocity. Okay. So A would have a greater change in momentum because it experiences the same force for more time. Okay. This idea of following through. Following through enables you to push, like stay in contact longer with the ball than you would if you just abruptly stopped when you came in contact with the ball, which allows you to change its momentum more than you would if you didn't follow through. So this is like a slow motion tennis racket hitting a tennis ball. If you didn't follow through, oops. Check out how this ball like behaves like jello. If you didn't follow through, you'd stop right there. But you continue to push, continue to stay in contact with the ball, so you cause the momentum to change even more until like that moment in time. But do you see like the of the tennis ball? Pretty crazy. Have a conversation.
I'm gonna say brick wall.
Tell them why you think so.
Greater or faster?
Greater.
Probably say they both are the same. It's just that
Correct answer is C. Okay, they've both experienced the same change in momentum. You got two different perspectives. This one's the definitive one in this case. They both have the same mass. They both started at 60 miles an hour. They ended at 0 miles an hour. Both experienced the same change in momentum. Okay. Now, here is an example of a brick wall. Okay. Here's an example of a hay bale. You know, big barrels that are in front of like overpasses, the pillars in front of overpasses, like that hold up the overpass. They're filled with water or sand. Okay. So, which car's momentum changed more quickly?
brick wall.
Everybody okay with brick wall? So it changes momentum quickly. Which one experiences a greater force? Brick wall. That makes sense? So in order for you to live, you want to change your momentum more gradually. That makes sense? Okay. So which one experiences a greater impulse? Watch yourself. Impulse is equal to change in momentum. Same. Last question. Correct answer is, what are you missing? Time. You need to know how long it took you to change this momentum. Okay?